Oops. Oh, come on. Shots how it works. All right, so usually I'd be shaking a cowbell right now, but more cowbell. Yeah, if you're new, it doesn't really matter to you, so pretend I didn't say that last sentence. I'm Christian. Usually Paul Weber's here. If you're not familiar with Paul, he's been running this thing for years upon years upon years. He's a Java champion. He's off having a great time vacationing right now. So he's asked me to help out. Set your phones to silent, so please make sure you turn off cell phones. If you want to use Wi-Fi, we have a guest network, password is sleep tight, if you haven't already noticed that. A little later we'll talk about this, but today our pizza's been brought to you by Proven Recruiting. So Kelly, in a couple minutes, yeah, maybe a quick thank you for the pizza. Everyone seems to have liked it because it's pretty much gone. Get it while it's still there. So here's the general timeline we usually use. So 7:50, we'll kind of start, and we'll do the intro right now. 7:50, we always take a little bit of a break. So one thing, and we'll get to that in a second, but one thing we do during the break usually is a raffle, or at least you can donate some money, because the way, when we can't get a sponsor, the way we actually pay for the pizza is through contributions from Java user group members. So I'll probably bring that up again here and there. Here's the trouble though. I completely forgot to bring the raffle winnings today. So there's, on one hand, no real raffle, but on the other hand, I would still love if you guys could donate to the Java users group. So there's a little jar here, and maybe I'll put in the first dollar when we break here at 7:50. Our speaker today is Paul. We'll get a little intro for him in a second, and then meeting ends at 9. So just a quick note, at 9, you can stick around and talk for a little bit of a second as I'm tearing things down, but we definitely have to clear up and get out. Usually we say about 9:30, but if 9:15, we can kind of clear out by then. That'll help out, because our facilities is really kind of sticking around to help us put this together. So our mission is to strengthen the San Diego Java community by providing an environment where our members can share their knowledge, discuss advances in related technologies, and promote Java. So as I mentioned, Paul's a Java champion. We have, if it doesn't pop up on the slide, I do want to point out right now, Paul, this Paul is now also a Java champion, along with Gail. A few months ago, another one that I was actually hosting, we had Gail and Paul presenting Java on mobile. Yeah, Java on mobile, which was actually pretty cool. It was using some interesting frameworks, kind of cross-platform support for Java on both iOS and Android. So a lot of cool stuff. If you want to become a member, we got a new site here. So previously we used to use the Yahoo groups. A little bit outdated, but I think more importantly, with 3 or 4 major security breaches with Yahoo, I think we were kind of done with it. And now we have a meetup. So feel free to jump on the meetup or the Facebook page. And becoming a member, just show up. And obviously, if you have anything you want to talk about, participate. Let us know, and we can schedule in. So, quick word from our sponsor, Proven. Kelly, you want to come up and say something? Yeah.
This is so after we have Proven is around for almost 10 years, representing the team firm. So if some of you want to work with us, international and impact, or just some of our pilot clients. That's actually find us as ours as well. We have a finance and accounting division and also technology. We're San Diego and LA focused only. So we've got some specialties there, small market, developing, consulting. I think everyone I talk to is happily employed, so the practice we feel, don't worry about that. If your company is looking to hire additional talent, resource us basically what we're here for. If anyone has any questions, like I said, feel free to add me on LinkedIn, and I'll
yeah, even if you're happy, you should always entertain the thought, right? Maybe, unless you work for Resident.
Yeah.
And as Kelly mentioned, we're partnered with Proven, so we can definitely recommend it. Pointing out that in March we have DevOps 2017. pretty significant here because this is here in the United States, first time that it's actually happening. So if you're interested, check out the site. This is a Java conference run by people who are really actively involved in the Java scene. So as I mentioned, actually it is here, it's perfect. So Paul is a Java champion, director at Anderson Software. As I mentioned, a wealth of knowledge across the board. Paul was even telling me that he does training, not just in Java, so Python as well, interestingly enough.
I'm teaching Python right now.
Yeah.
Pretty interesting.
Yeah, it's pretty cool. So member of NetBeans Dream Team, author of 8 textbooks on software programming, and I won't even dive into the rest. Maybe you'll say something here and there. But visit asgteach.com, please. So last but not least, I guess we're pretty much done. So yeah, want to just thank ResMed. We try to do it here every month. It's been here for quite a while. Like I said, a lot of orchestration happens with our facilities team and our IT team to try to get this all ready for you guys. So just, thank you to ResMed. And let's hop over.
Just go.
Oop, that's that way, that's why. Yeah. There we go.
Okay. Oh, it's not coming up. Interesting.
There we go. Take a second.
Okay. Okay, I want to welcome everybody. This is my second time here. As Kristen said, I was here before last fall to do a job on mobile. Maybe some of you folks were here. Yeah, so this is my website here. I'm local. I live up in Encinitas, and I do a lot of training courses all over the country, actually. And I'm doing a lot of training courses at Teradata. In fact, I taught a Java 8 course at Teradata last year, and so I'm very active, in the Java community. In January, we were approved as Java champions by Oracle. So, I met Paul last year at Java 1 conferences because I speak at Java 1. And also, speaking of DevOps, we were over in Belgium in the fall to do DevOps there, and speaking at Java 1 as well. So I'm pretty connected into the Java world through Oracle and everything like that. So if any of you have any questions about, just directions of Java and maybe Java 9 and things like that, you can go ahead and talk to me during the break, and that's fine. Okay, so basically what I told Paul that I would do is I have a Java 8 course that I've been teaching for about 2 years now, and I thought what I could do tonight is just go through, pull out some of my slides and some of my programs and just show you some techniques that you might want to do. Now, how many folks, how many of you guys are using Java 8 at this point? Ah, great, okay. So I'm going to be talking about lambdas and streams, and some of these things you might know, but you probably will learn some new things tonight. And for those of you that haven't been using any of the functional programming additions to Java 8, I think you'll find this all very interesting. So what I'm going to do is I'm going to do lambdas in the first part, and motivate a little bit for what we're going to do, and then in the second half after the break, I'll talk about streams. Okay? And again, I'm just going to be pulling out selected slides out of my course and talking about areas of Java 8 that I think are important and that you want to use and be proficient in as well. Okay, so now and just real quick, my course is set up as Lambda. We do Lambdas in section 1. We do Stream API in section 2. And then in section 3, I spent a lot of time showing people how to refactor. Take the existing Java code that you have now and upgrade it to Java 8. And that's something that a lot of people don't talk about. They teach you all the new stuff, but they don't show you how you can refactor some of the design patterns that you have and all that sort of thing. And I'm not going to actually I'm going to do one of these tonight, but maybe if ever another time I can show you that. And then the other part of Java 8 is there's a lot of enhancements to the concurrency model. So there's a lot to talk about here, and I won't be doing these two sections tonight. I'm just going to do a quick intro on Lambdas and also streams, and then show you guys some techniques and things. So let's get started. Okay, so the big thing that they added into Java 8 that kind of makes everything go is the idea of a functional interface. And we all know what an interface is, right? But a functional interface is actually annotated in Java 8 with the @ functional interface, which is actually just a tag. It's sort of like serialized, right? It doesn't actually do anything or decorate the interface itself. It just tags it as a functional interface. But a functional interface is an interface that has exactly one abstract method, not 2 or 3, but just one. Okay, and because we have these functional interfaces, then we can use them with Lambdas, and then with Lambdas we get the power of functional programming. So to take a look at some of the interfaces that you already know from previous versions of Java, these things have been upgraded now in Java 8 to have the functional interface annotation. For example, the comparator interface has one method, char, generic, right? The runnable interface, which all of you know with threads, right, is going to have one abstract method, run, also upgraded to a functional interface. I also teach a lot of JavaFX courses. How many folks are using JavaFX here? Okay. This is actually an event handler in JavaFX, so don't worry too much about this. And then this is another callable that's like a runnable, except that it has a return type, you know. And again, you know, that these are all been upgraded to be functional interfaces in Java 8. Okay, so what this means is that if you take a look at some functional interfaces with some code that you know, what you can do is you can say, okay, I know what runnable is, and what you're used to doing is things like this. And you know, this is something that I always found interesting when I was teaching Java, and I've been teaching Java for a long time, for 10 years. And anonymous classes are always tricky to teach people at the beginning. And here's why, right? When you show people the named class approach here, where you say my class implements runnable, and then you override the run method, it's easy to show people that you would do the my class over here and build an object that passed to the thread constructor and then start up the thread, right? But when you show people an anonymous class, it really bothers them. And the reason is because they see the keyword new, and then they see the runnable, and runnable is not a class, it's an interface. So right away, this confuses people when they're learning Java, because they say, well, gee, you know, how can you do an interface? In fact, the syntax is a bit brain damaged, actually. But of course, all of you know that what's really happening behind the scenes is that an anonymous class without a name is being created that implements that runnable interface, and it's in that anonymous class that the run method is done, right? But this syntax has always been clumsy, right? And that's what Lambdas do, is they help simplify this, right? So let's show you that now with the following some examples on Lambdas, and then we'll go back and we'll show you how this can be simplified. All right, now if you don't know what a lambda is actually, Alonzo Church is the mathematician that came up with this concept a really long time ago. And it's a mathematical concept that represents a function that does not have a name, but you use it so that you can pass code as arguments to other functions and then have those functions execute that code at a later time. So that is what they added into Java 8. It is a Lambda expression that has these two formats that you see here. This is nothing more than a signature that you already know from a method in Java, parameter list. And then you have the arrow symbol, and then you can either have a block of code with braces in multiple statements separated by semicolons if you want, or you can just have a simple expression. So here are some examples of what the Lambda syntax looks like, and these all represent certain things that we can do, and I'll be showing you how to apply these Lambdas here in a minute. So the simplest one is the one at the top, and all you have to do is just, if you haven't seen this before, is when you see int x right there, just put like the name of a function in front of it, like f. And then so you say f is a function that has one argument that's an integer. And then and instead of the arrow, you would have a left brace return x1, x plus 1, semicolon, right brace. And therefore, that represents something that you're used to seeing. But the compiler will do that all for you now in Java 8. It'll take these expressions and it will generate the function calls by using an anonymous function name under the hood. The second the second example has two integers that add something together. The third one is a couple of doubles that you're comparing. And then when you go down and you see some of these other ones, you can see that you can create a lambda that will tell you the length of a string, whether a list is empty or not. You can print something out. You can create a new person on the fly. You can determine a Boolean expression for if a person is a teenager, right? Which is what that does. And then you can even have a lambda which has a block of code where you can write code. And you don't want to write a lot of code here, but it is something that is done. Okay, now what do these lambdas do that help you out here? Well, here it is. The first thing that you can do is you can go back to this example where we had this kind of clumsy syntax for an anonymous class, and look what we can do now. This is what Java 8 brings to the table, is that instead of saying new thread and then new runnable, where an anonymous class is created that implements that interface, you get rid of all that boilerplate code, the override, everything, and you substitute in a lambda expression, and it works exactly the same. Now you can recognize what's happening here, because if I take the left paren, right there, that is representing the run function right there, except that the run is anonymous. And then on the right side of the arrow is the code that is going to be executed inside of that lambda expression. And that would be this code right here. So you can see how this works. And what's happening is that in Java 8, when you use a lambda expression, the compiler will generate the anonymous class for you under the hood behind the scenes. But look how simple that code is. Once you start using lambdas like this, it really, really simplifies things a lot. Okay, so enough talk. Let's look at an example now. And I'll bring one up right now, and we'll run a program from my class, and you'll see what's going on here. Okay, so I think everybody can see that. Okay, so I need a class to work with. Let's just use a POJO. Plain old Java object doesn't implement any interfaces or extend any classes. That'll be a person. And a person has a first name, a last name, and an age. And then we have 4 constructors that you can see there. 4 different ways to build a person object. Okay? All right, now what I'm going to do that's going to show you what this is I'm going to make up my own functional interface here called myPredicate, and it's going to have one abstract method in it called test that is going to test whatever's passed to it, and it's going to return a Boolean. Okay? All right, so what I'm going to do is I'm going to go over to a program now, and I'm going to create some people. Okay. 3 people with different ages, and then I'm going to write some regular Java code that would go through and filter the list looking for people who are, in this case, over 30 years of age. So, if you don't know about functional programming in Lambdas, this is the kind of code that you would write. So, you would have an anonymous class here with the interface. You write the test function, you look for somebody who's over 30. In this example, you look for somebody whose last name is Jones. Okay? And the code that you would write to do this filter list, would be generic, and it would look like this. And you can see that inside the filter list method there is you create an empty list, you set up a for loop, you go through each item in the list, and you test it to see if the person is over 30 or their last name is Jones or whatever, and if so, you add them to the list. And when you run this program, which I can run right here, the answer will be Ted Jones is over 30, and Peg Jones and Ted Jones come up because their last name is Jones. All right? Okay, now, here's the fun part, right? When you're in an IDE like this, and I'm using NetBeans, these IDEs will help you convert your code and refactor it to Java 8. Watch. There's a little bubble over here. I don't know if you guys can see it, and I don't know if you can read that, but it says, hey, this anonymous inner class can be turned into a Lambda expression. So if I click this and click on this, the IDE has just put a Lambda in there for me. I didn't have to write it, it did it for me. Let's see if it'll work down here too. Here's another bubble. Click on it, use Lambda expression, and bingo. I now have a Lambda expression down below too. Everything still works, of course. If I compile and run the code, it all works, right? Okay, but here's the cool part, right? I'm going to go down here now, and I'm going to get rid of my class and call it predicate. And of course, I get a red line in NetBeans because it's saying I don't know what that is. Well, it turns out that's in the Java 8 API. So if I go up and I say fix imports, and I pull in the import for it, now I'm using the predicate, which is a functional interface in Java 8, and I don't even need the one that I did anymore. You know, this one. This one I'm not even using anymore because I'm using the one that's with the system, and then everything works great. Okay, so what did you just learn here? You learned a lot, right? You learned that there are functional interfaces that are already defined in Java 8 for you that you can use. You learned that a predicate is something that is a Boolean that will give you a true or a false situation. And you also learned that if you use an IDE like Eclipse or NetBeans, they can help you refactor your code, because I just did that, didn't I? I got, you know, my code used to have anonymous classes, and now they're all Lambda expressions. Okay, so that's good. IntelliJ is another one. Yeah, so the big ones are Eclipse and NetBeans and IntelliJ, and then there's some other ones too. But most of them that are all wired these days to help you convert your code, because it's, you know, it's built into the IDEs that they can recognize the fact that a Lambda expression can be used here. Which one? Maybe, yeah, I think it is actually, yeah. So, you know, if you use an IDE like I do, this can really save you a lot of time for, you know, getting, not only can you learn about Lambdas, but you can refactor your code too, because the IDEs all know how to do this sort of thing. Okay, now moving on. There are a number of different interfaces that you can choose in Java 8. And this is the one that I just showed you. I just did that one right here. That's the Boolean, the one that takes a generic type and gives you back true or false. Notice that there's also a consumer and a supplier and a function, and you know, it takes some time to have to learn these things, right? But they're really, really powerful because you can use these in your programs, and they will do a lot of the kind of work for you, just like I did right here at this point. Okay, so let's take a look at how we might use some of these things. And the way we'll do that is I'm going to go back here for a couple slides to show you guys another new thing another thing that's in Java 8 that you should know about too, and that is a method reference. Now, method references are really cool because a method reference is a shorthand notation for a lambda. So you guys have seen lambdas now. Now we can tell you that, you know, there's the syntax for Java 8 is you can make up a method reference with a new operator that they added, which is : : And by the way, if you guys know some C++ out there, you'll recognize that operator is, you know, it's used in C++ too. So it's also now used in Java 8. Okay, so real quickly, we'll go through a couple of examples here. Here's a lambda on the left where an anonymous function has one argument and it's a string, and all I want to do is convert it to uppercase. I could type in this whole lambda expression if I wanted to, and it would work just fine. But I can also now do this. And this is easier to read, and it's easier to type, and it is the same thing, right? It is a method reference that generates the lambda expression on the left, And as you glance down and see some of the other examples that I have up here, you can see that it's a lot easier to use method references when you can than to use Lambda expressions, you know, because these things are just easier to read and easier to use. And these are the formats that you can use. And you know, I'm not going to go through all the details of that right now, but you can see on the left here that you have these Lambda expressions here, or can all be used as method references on the right. All right, now we need to look at some real examples of this. You know, so let's do that now. And we'll do that by showing you this slide right here on. Seems like we're jumping around here a bit, but I'm just pulling up stuff here that I wanted to show you. Okay, now the one thing that the method references really help you with are building objects at runtime with what's called a constructor reference, rather than using the traditional new that you guys have seen before. So once again, the format is a method reference where a class name is on the left-hand side of the colon, and the keyword new is on the right side. So what I'm going to do is I'm going to show you that we can build, you know, remember my person class has 3 different constructors. There is a default constructor with no arguments. There is a constructor with an integer argument for an age. And there is a constructor with a name and an age. And then there's a constructor with a name, a first name, a last name, and an age. Okay, so you can see as you glance down these examples, in the comment, this is what you would normally do, is you'd say person P equals new person. But in Java 8, what you can now do is you can declare a constructor reference, which is a supplier, and it's typed as person. And then you can say person : new. And then when you do that, and you call the get method, and that will call the constructor, the void constructor, and build an object for you with the default constructor. Because you'll see in the next example. And by the way, I am not saying at all that you don't want to do this anymore. You know, you do this. No, I'm just teaching you the syntax right now. Okay, you wouldn't do it. You would not do this, but it helps you understand. So notice that the one argument constructor is going to take the functional interface. The 2 argument constructor is going to take the bifunction interface, and we can even do the 3 argument constructor with making up our own. Okay? All right, now let me show you what you can do with this. That's really cool, because we need a real example now, right? So here it is. All right, let's suppose that we are designing a system that has packages, okay? And we have packages that have weight, and we have names for them, and we want to build a hierarchy of different kinds of packages. So we have an abstract class that describes what our package is, that has a weight, and we have a toString method that will print out the name of the package and its weight. And then we have different kinds of packages, like a box is a package, and a box has weight. And we have a book, which is a package, and a book has weight. And we have a crate, you know, larger kind of thing that, you know, that we can put larger things in, a crate of some kind, and that's a package, okay? So we set up our hierarchy like we normally do. All right, now this is where the constructor references can come in very, very nicely. Okay, so if you want to write a program and create different kinds of packages, well, a lot of times what you will have to do when you're writing a program is you don't know always at compile time what objects you need to create until you run the program. And I'm simulating that in a way here because I've got box here and book here and crate. And you know, these could be read in by XML files at runtime or something like that. And I need to create a box object and a book object and a crate object from the string names that are coming in. And that's what this program is doing. Okay, now this is a way to do that that a lot of you have probably never seen. And this would be to use a hash map in a very interesting way. What you would do is the map the key for the map would be the name of the object that you want to create, and the value of the map would be a functional interface where you're using the function, and the argument for the function would be an integer, and the package name would be the value, and you would build a hash map with this. And now you can use a static initialization block, which is a way to load the map. Do you guys know about static initialization blocks? You know, they run before the constructors do, so it gives you a chance to initialize things. This is a great way to load up a map that you need when your program runs. So you set up a static initialization block and you populate the map with the name of the object that you want to create and the constructor references. And it works great because when you run this program, you create a box, you create a book, and you create a crate. And I am doing that with no news here at all. I'm doing it through constructor references that I showed you the syntax for, and I'm using a hash map to make that happen. So does everybody see what I did here? It's pretty interesting. You know, this is the classic case where you have an XML file that has types out there, and your Java program has to configure itself at runtime. When you write the program, you can't do news, because when you do a new in Java, you have to put a type after the keyword new, and you don't know what the type is. When you write the program, you have to determine the type at runtime from a string. And there are lots of factories out there that do this, but none of them really look like this. This is a much better way, I think, to do it in Java 8 than to use some of the clumsier methods that you guys have probably seen out there with other things. And when I say clumsy, I've seen people implement this with switch statements. Have you guys seen that? You switch on box, switch on book, and then you do news. And that's not so great, right? Because what happens when your boss says, oh, we got to add 3 more packages to the system? What do you have to do? You have to go modify, to find all the switch statements, and you have to fix them all. And all I have to do here is populate my hash map with, and remember, in the real world, I would be reading the strings, box, book, and crate. I would be reading them from an XML file, and then I could create the objects for whatever configuration that I want. Everybody see what I did here?
So really, you're saving that new statement, you're storing that new function call.
Right, right. Yes, that's exactly right. Right, and I'm building objects on the fly from string type names here, but I'm not doing it in the clumsy ways that we have had in Java before this stuff came along. So I think this is a good example of what Java 8 brings to the table, and how you can use some of these things.
What's the
Get package?
Yeah.
Oh, that's just down here. That's where we go into the map, and we have the name, and then we call apply, and that calls the constructor and builds the object. Yeah, and you know, if you go out to see remember in the predicate we had the test method. Okay, in the functional interface, there's an apply. But what you're doing is you're applying whatever you put here. See, so when you call apply right there, you're actually creating a new box and calling the constructor. And remember that the constructor that we showed you on the previous slide has a weight. See, right here, and so that's where the weight comes in, because there's the weight. So when you call apply right there, that's calling the constructor for either the box, the book, or the crate with the weight. Exactly. Right. So when you say map.getName, you get back the value, which is a function interface, and then you call that one for a box, this one for a book, and this one for a crate. And that's what's happening here. Yep. Yeah. So This is an abstract class with a package, and it manages the weight, and there's a get weight and a toString. And then all the other guys do is a box, book. They all have weights, and they just call super to store it there, right? But they all have weights, and that's why I can do. That's why I can call the apply right here, and under the hood, I'm calling the constructor for either the box, the book, or the crate at runtime without knowing when I write the program what types are. Yeah.
So you have there's guarantee getting accepted from the package parameter also the crate.
Oh, you mean if I put the word Fritz in here or something like that? Oh yeah, I don't have any error handling in here, and I don't have any exception handling, and you would have that, right? You would want to look for something in here that was correct, right? So, and I don't have that here, but you'd want to add that. No, the exception would be thrown. It wouldn't be caught, but you'd get an error. And
something like that scenario, you leverage the map,
right?
Leverage the map as a factor, so you just stick that in your return. You wouldn't even have to add an exception. Right. Okay. So. Oh,
right. That's true. That's right, because if you gave it like Fritz, it wouldn't be in the map.
So I mean, maybe it's right.
Yeah, could be.
What happens when you call apply? Is it going to do a null pointer exception, or apply just doesn't really work on it?
Well, apply is a normal function like anything else. So when but weight is an integer. It's not an object.
No. When you say map.getName, you get a null. Are you calling apply on all you get a null pointer?
So you would have to do it.
You'd have to do a null check.
So you would get a null pointer.
Yeah, you would. Right. Remember, you could add the error checking in here. I didn't do that. I'm just concentrating more on the mechanism behind the map and how that would be done.
Apply is something that happens. It's not like a normal.
Yeah, it's all exactly the way that you would say. So yeah, you could get a null pointer exception if you got back a null right there. So in the real world, we would want to fix that or check for null. By the way, while we're talking about checking for nulls, there's another new class in Java 8 called optional. And if you know about that, you don't have to check for null pointers that much anymore, because the optional class wraps a null pointer for you and checks everything for you. And you can use those in streams, which I'm going to talk about after the break. But at any rate, this was something that I wanted to show you. Okay. All right. So what else can we do? Show you here with Lambdas that is interesting. We can show you some techniques for chaining these things together. So let me show you this one right now. Let's see. I want to go back one more. Okay. Now, once you start getting using Lambdas, there's a lot more to Lambdas than just using them as in event handlers, which I showed you, or with the underlying mechanism of a method reference. You can also do Lambda compositions, where you can combine Lambdas together to build more complicated ones, and you can chain them together so that the result of one Lambda the output of one Lambda can be the input to another one. So again, we can do some interesting things here with these. Let's go back and show you some code snippets with what I'm talking about. Let's start off with these people again, names and ages, and they're being stored in a list. And what I want to do now is I want to sort them by increasing age. Okay? Now, if you had to do this and you weren't working in Java 8, you would not do this in one line of code. You have to write more code. But I can do it in Java 8 with one statement. I can say list.sort, and then in the comparator class, I can call the static comparing method, and then I can give it a method reference. Another example of how a method reference can be used. What I'm doing here is that in the comparator class in Java 8, it has been upgraded in Java 8 to work with lambdas and method references. So what I'm doing now is I'm telling sort in the collection class to use the comparator object, but when you go to compare to the comparison that's being done is a person's age. And I told you guys that, you know, method references make the code really easy to read because it's obvious when you look at this that what you're comparing here is going to be someone's age. And so when I run this in a program, what will come out is you know, is a list where these people are all the 3 people that we have is sorted. So, you know, Jane is the youngest and Ted is the oldest. But I'm doing this in Java 8, one line of code. Now that was increasing age. Now what if you said, well, but I wanted to go decreasing age? Well, look at this. You can do exactly the same thing, but they have building patterns written into these things. So you can say, you can have the list.sort, and then you can tack the .reversed on at the end. And now the sort will be done in the opposite order, and now Ted, the oldest, will be first in the list there, and David will be in the end. Actually, they're the same age, so you know, it comes out like this, but you get the idea. All right, now how do we do sort by decreasing age and first name? So you can, what we're doing is we're showing you these are like query kinds of concepts, aren't they? And when we do these kinds of query things, we can implement them much easier in Java 8 when we get comfortable with these kinds of things. So now what I'm going to do is I'm going to sort all the people by their age, and then I'm going to reverse it, meaning that it'll be decreasing age first, and then I'm going to use the builder pattern to go out and get another method that can be called here, called then comparing. And then I use another method reference that says I want to pull out all the peoples by their first name. So now what I get is I get everybody sorted, but their first names are being involved as well. So this is an example of how you can use method references and how you can chain these things together so that you can do query type concepts without writing any loops, without creating any array lists, and without working too hard like we've been doing before. Let's look at another one. This is the one that I showed you guys earlier. Again, we got a list of people, and I did this filter list for you. Remember, I went in and I showed you the predicate right there. And after the break, I'm going to show you how to simplify all this code too. Because, you know, that's very much a Java idiom out there where you say, create an empty array list, set up a for loop, go find what you want, put it in the array list, and then return it back. And we're going to show you after the break tonight that I can use streams to do that. And now that's going to make things even better, right? But let's not do that yet, because we're still looking at lambdas and method references and things like that. Okay, so this is the code that we've written, and it works just fine. So now the question is, okay, how do I find people who are under 30 years of age? Okay, well, what you can do here is you can make up a predicate. Here it is, it's a lambda. Right there. So P is a person. You go out and get their age. If they're under 30, then that will be true, and if they're not, then it will be false. So what you can do is you can take a lambda and you can assign it to a variable as long as you type it correctly, and of course it will be a predicate, and it will be, the type will be for a person. And then I can take that predicate and I can pass it to my filter list, the function that you see up above, the method up there, and then I can get a list of people who are under 30 years old. Okay. All right, now, what if I want someone who's under 30 with a specific last name? Okay, well, I already have the predicate that says someone is under 30, that's pred1. Now I can make up another one called pred2, and I can take a person and I could say, is your last name Jones? Yes or no, true or false? Okay. And now, this is the cool part, right? Is that when I call my filter list, instead of passing one predicate there, I can add them together. So I could say, are you under 30 and is your last name Jones? And when you run the program, the only person that comes out is Kay, because she's under 30 and her last name is Jones. Yeah.
Where is that and defined? Must be defined in predicate?
Yes, it's defined in the predicate class, which is part of Java 8.
You only have one state defined predicate.
No. Those were a functional interface has a method, but the dot and is done differently. Yeah, and there's also an or. So in fact, I think I can end with this program. Yeah, here. Let's show you another program that uses this here. We can go one step further here if we wanted to. Let's see. I think the one I want is for composing predicates. Yeah, there it is. Okay, so here's the actual program. I had snippets of it in the notes, but the under 30 method there is what you saw, the under 30 with last name, and then I did one more. People who are under 30 with their last name being a specific name, or they're someone who's over 40. And what's interesting about this is that you can have an or in your Lambda compositions too. So you guys saw all of this code right here with the pred1 and pred2, and now here is cool part. You can also take it even farther if you want. So now we have 3 predicates: pred1, pred2, and pred3. Pred1 is what it was before, people under 30. Pred2 was their last name is Smith. And pred3 is going to be someone who's over 30. So now you could call the same filter list, and you could say pred1 and pred2 or pred3. So what you're doing here is with cascaded dots and with the builder pattern, you're implementing logic, right, in your program so that you don't have to write these if statements and write a lot of boilerplate code. And that's what's cool about this stuff. Takes a little bit of work to get good with this, but once you start doing it, you really like it. And Java 8 has really helped out a lot now for making people be able to do these kinds of things without writing a lot of boilerplate code like we've been doing before.
That's the
So if we go look at the Java doc for the predicate here,
Pretty much going to be left to right.
so I didn't get into default methods because that's the answer to your question. You were saying, wait, I thought there was only one method in the interface. If you look at the predicate interface in the Java 8 docs, you'll see that. Let me see if I can make this bigger. That's better, right? A little bit bigger, maybe. Okay. So you can see that it is a functional interface, and it was introduced in Java 8. So there it is.
I think the whole question was, my understanding, how the precedence will be applied, right? I assume
it's going to be left to right. It's left to right.
And the second one, eventually the result of that process.
Right.
okay, so
Yeah, that's it. And can you see that the or and the ands are in here? But look on the left. These are defaults, which is another brand new thing. I didn't have time. I can't do everything in the time that I have here, but I have a whole section in the course on default methods too, and these have all been added, and these are the ones that show up here. So you have the test, which is the single one that that's not defaulted, and that's the one that the functional interface uses for lambdas and for method references, and then the other ones that you're using are defaults, and these can be chained together and they will evaluate left to right. and you can find those out there and see how they work.
Predicates based on certain object types. So I know that I'm going to deal with first predicates. Is that any way of organizing it so that the data is looking higher rather than
well, if your question is, remember that all of these things that you've seen are generic. So there's going to be extensive type checking being done. So if you don't wire it together right and you don't have the types right, you will get type errors that come back, and that will tell you that you don't have it constructed right. But you can see, pred1.and and pred2.or and pred3, those all have to be not only predicates, but they have to be the same type too, right?
So if I have one predicate related to person object and organize together, then somebody else could be kind of checking at the library essentially what kind of predicate I have.
You mean can you query a predicate and find out what type it's wrapping? Is that your question? I think so. I'm gonna have to look into that, but I think that you can query a predicate and find out what type that it's working with. I don't have an example or anything like that, but I think you'd be able to do that. Okay, so that's pretty much all I had time to show you at this point. If you haven't seen this stuff before, I would highly recommend that you get a book on it, functional programming or Lambdas or whatever. A lot of good stuff out on the web too with tutorials. Remember that Java is still, you could use Java 8 all day long and not do any of this stuff, but I think you're missing out if you don't use it. I think it's worth it as Java developers to learn these things, to see how they work, and then you can decide how much you want to use in your code and what you don't want to use. It's like anything else, right? But in the limited time that I had here, I just wanted to show you some techniques that you can use here. And again, this stuff is not going away because Java 9 will be coming out hopefully in the fall. We'll see. And of course, Java 9 is an upgrade from all this, so this stuff's not going away. It's going to continue to be there, and it's just a matter of time before everybody starts, doing this sort of thing, getting away from the boilerplate code that we have been doing for so long in Java. Once you start doing this stuff, you go back and you look at your old code, and you go, "Wow, I was really working hard here, writing a lot of code." You're getting down to stuff that's a lot simpler here. Okay.
We'll take feel free to keep talking during the break. We'll take a quick break and then regroup.
Yep.
So as a reminder, as I said, taking donations for Java user group.
Is this a jar file?
Yeah, there you go. Here's the jar.
Here's the jar file.
I'll post with the first time. I appreciate it. So just in case we don't get a sponsor, in the future, we make sure that we have something to pay with.
It could be anything.
I'm saying you can leave out the word fly.
No, you have to